Okay, let's solve this LeetCode problem. Find champion 2. There are n teams numbered from 0 to n-1 in a tournament. Each team is also a node in a DAG. You're given the integer n and a 0 index to the integer array, edges of length m, representing the DAG, where edge ui, ui, vi indicates that there is a directed edge from team ui to team vi in this graph. A directed edge from A to B in this graph means that the team A is stronger than team B. The team B is weaker than team A. That is the meaning of a directed edge from A to B. The team A, then it says the team A will be the champion of the tournament if there is no team B that is stronger than team A. We have to return the team that will be the champion of the tournament if there is a unique champion, if we can identify uniquely a champion. Otherwise, return -1. Then it gives some notes here. A DAG, it says, is a directed graph that does not have any cycle. I'll tell you what a cycle is. It's pretty intuitive. Let's look at the example 1. Let's first read this graph. What is it trying to tell us? So in this case, we have a directed edge from 0 to 1. It means the team A, team 0, is stronger than team 1, and team 1 is stronger than team 2. You can see that the champion, it says the champion is the edge, is the team where there are no teams that are stronger than this team. So in this case, the champion 2 cannot be champion because the team 1 is stronger than 2. The team 1 is not a champion because team 0 is stronger than team 1. The team 0 is a champion because there are no other teams that are stronger than team 0. In this case, the answer is 0. The example 2, in this case, we can see that the team 1 is stronger than team 2 and team 3, and there are no other teams that are stronger than team 1, and team 0 is stronger than team 2, and there are no other teams that are stronger than team 0. We have 2 champions. In fact, we have no champions in this case because we cannot uniquely identify which one is the champion. We have 2 teams for which this statement is true. Team A will be the champion of the tournament if there is no team B that is stronger than team A. This is true. For B, we do not have any other teams that are stronger than team B, team 1, and for 0, it's also true. So we have two such teams, so we cannot determine which one is the champion. So we turn -1. Now let's see how we can solve it, and also let's go over briefly go over the basic terminology of graphs. If you're already familiar with the basics of graph, you can skip forward. In this problem, the graph is very explicit and the relationships is shown. Like a graph consists of multiple nodes or vertices that we call them vertices. These are some objects, or these are some real entities. This could be, for example, people, the people A, people B, and people C. And there's lines connecting them, which we call them edges. This edge shows the relationship. This is an undirected edge because there is no direction specified in one direction, in one side. That means you can go from this side here and from this side here. So basically, an undirected edge is two-sided. You can go here and you can go here. There are two directed edges, just shown like this, a single line. So this line, what this line represents, as we said, this could be a friend, a friendship graph. Let's say we have A and B. This 2 represents 2 people. A is a friend of B. Let's just say A is a friend of B with this directed edge. We see this. If we see this edge, this means that A is a friend of B. Now let's see here, C. Then if we see C here, then we say, okay, B is a friend of C. And we can also have two edges like this. But as I said, this is just, since it represents both direction, it could just be a straight line. If we have here D, that means C is a friend of D, and D is also a friend of C. That is basics of graphs. So when you're given the graph, you're given the vertices, and you're given the set of vertices and the set of edges. Now, let's talk about a property of graph, or a basic terminology of graph, which we will use in this problem. You see this, let's just make this a directed edge. In this graph, you can see this B into this vertex B. There's one arrow, there's one vertex that goes into this B. This is called the in degree of vertex B. The in degree of a vertex is the number of directed edges that enters this vertex. There's only one such arrow that enters this vertex B. So the in degree, let's just call it in, the in degree of vertex B is 1. And we have also the vertex from this vertex B, we also have an arrow that goes to somewhere else, to another vertex. This is called the out degree, the vertex that just leaves this vertex, the edge that leaves this vertex and enters another vertex here. So this is called the out degree. I guess I have mistakenly called this edges, vertices, so don't be please confused. So the out degree of B is equal to 1. And for example, for C, there are two edges that come into C. The in degree of C is 2. And there are no edges that comes out of C, so the out degree of C is 0. Okay, this is enough in order to solve this problem. Let's now see how we can solve this problem. If we look at the first example, there were 0, 1, and 2. From 0 to 1, there was a directed edge, and from 1 to 2, there was a directed edge. In this case, this relation, this edge, means the relation a team 0 is stronger than team 1, and team 1 is weaker than team 0. So you can ignore this second part, just focus on the part that one team is stronger than the other. So in this case, team 0 is greater than team 1. We have to find the champion. But which team is the champion? The team is a champion if there are no other teams that are stronger than 0. In other words, there are no edges. There are no edges that are directed to this this vertex. For example, for 0, there are no such edges. That means there are no other vertices, the other teams that are stronger than it. So this relationship for 0 does not exist. 0 is only stronger than another team. So we have to find the champion. The champion is the champion team. The champion team is the team that is stronger than not stronger than every other, but there are no other teams that are stronger than 0. In other words, there are no arrows coming into 0. So what we said, the arrows that coming into the vertex, the edge that are directed to a vertex is called the in degree of this vertex. So if the integrity of a vertex is 0, this vertex could be this node could be a candidate for a champion team. Why did I say candidate? Because there's another requirement. The champion team, should be unique. If there is, in this case, we can see that the integrity of this node is 0. The integrity of vertex 1 is 1 because there is one edge that come into it. And the integrity of 2 is 1. So if we look for a vertex with integrity 0, we have 1 and it is unique. So then the champion is team 0. But in the second test case, we had 0, we had 1, there was, I guess, there was 2, and there in the C, and there was also 3. The integrity of 0 is 0. The integrity of 1 is 0. The integrity of 2 is 2. There are two edges that come into this vertex. And the integrity of 3 is 1. There are only one edge. So we're looking for the champion. The champion is the one with integrity 0. There are two such vertices, so we cannot determine which one is the champion. So it has to be unique. So in this case, we return -1. So for this problem, it is enough to count the integers. It is enough to calculate the integers of every vertex and check that there is if there is a unique vertex with integrity 0. Now let's code this solution. Okay, as we said, we're going to find the integers of every vertex. Let's have a vector of integers for every team. So we have integrity of n. Right, then we go over the edges. Let's just go over every edge. And then the edge 0, edge 1 means that edge 0 is stronger than edge 1. So the edge 1, the arrow comes from edge 0 and enters edge 1. So the edge 1, the integrity of edge 1 increases. Integrity of edge 1, we just increase it. And then we count the number. We're going to keep a count, and we'll have a team. So this team will be the champion if there is a unique one. Then we go over every team, and for every team we check if integrity of this team is 0. Then we say, okay, we found a team with integrity 0. We just increase the count, and we set the team to this vertex, to this team, the current team I. So then at the end, we say, okay, if the count was 1, if we have only a unique, if we have a single vertex with integrity 0, then in this case, we'll return the team that we found here. Otherwise, it's not possible, so we just return -1. So if we run this code, okay, it gets runtime 0, and then let's just submit this. Okay, here's the result. I hope you learned something from this video, and if you liked the video, just hit the like button to just support us. So see you in the next videos.